Hello and welcome to Pre-Calculus. Today we are going to take a second look at graphing equations in polar coordinates for the case of a circle. Let's take a look at this problem. R is equal to 3 cosine theta, and last time we explained how to quickly graph this thing by converting it to Cartesian and graph that. So the shortcut was that this is going to be a circle whose diameter is 3, and the end of the diameters are the point 0 and 3 itself here. Now what we are going to do today is to actually use this graphing facility to do the job and see what happens. So we are going to do point plotting. So here is a point we want to plot, and it's asking us where do you want to plot your point. So we are going to start theta, for example, at 0, and then move up and get points little by little. So if theta is equal to 0, start at 0, cosine of 0, we know it is 1. 3 times that becomes 3. So this is point 3 and 0. 3 and 0, as we expected, shows up here. We say, okay, let's plot another point. Now, here are some of the famous angles. We can use just those things to get an idea of what picture is going to look like. So let's move up to pi 6. So I have pi, pick pi from here, pi 6. Cosine of pi 6, we know it's radical 3 over 2 times 3. We have to write the exact value, so it's going to be 3 square root of 3 and then divided by 2. So that's going to be the next point up here. You notice that it is graphed on the ray with the angle pi over 6, and we have gone out as much as what this thing is. This is radical 3 over 2 is about 0.8 or something, and then times 3, 2.4. This is approximately that point. Next point up, pi over 4. So we are going to practice this thing again. So pi over 4, and then square root of the cosine of that is radical 2 over 2 times 3, 3 radical 2 outside divided by 2, and that's going to be another point. So we went on the ray with the angle pi over 4 and landed at this spot. Now let's go to pi over 3. So pi over 3, cosine of that, luckily that's a rational number, is 1/2 times 3. It's going to be 3/2, so it's 3/2. So that's another point that I have. Now let's go another one. So at pi over 3, our distance out was 3/2. How about pi over 2? So I go here, pi over 2. Cosine of pi over 2, of course, is 0. Multiplied by that, by 3 is still 0. So that is where we are landing. So far we have gone through 0 to pi over 2, and then we have gone through half of the circle. If I continue, let's for example go to 2 pi thirds. So another point, let's choose here. I choose 2 pi third. Cosine of 2 pi third is minus 1/2 times 3 is going to be minus 3/2. Okay, so what happens, a ray opening up in this direction, going out in this direction. When we have a negative r, means we have to back out, go to the other side. You notice this is symmetric image of that one down here. So same points are going to show up now. Next one is 3 pi over 4, 3 pi over 4. By now we have an idea, well, it's a circle, it's going to circle here. and we can go back to that panel and complete our circle. But just as a matter of practice, 3 pi over 4, its cosine is minus radical 2 over 2. So I have here minus 3 times radical 2 over 2. And we go one more, 5 pi 6. So here I have 5 pi over 6, 6. Cosine of that is minus radical 3 over 2. So you will need to have this table in front of you so that you can quickly judge what you're going to have. So I'll have here minus 3 square root of 3 over 2. And we check that this is symmetric image of that one down here. And one more. By now our circle is complete, but just to see what happens to pi, here is pi. So this is the ray that's going out. Cosine of pi is going to be minus 1. We want to go to minus 3. Minus 3 means going back in this direction, and we are going to land back where we were, minus 3. So that brought us back to where we started. So the cycle is completed. Notice one interesting fact. When you go on a circle directly, you go through 0 over to 2 pi to make one complete rotation. But when we look at this polar curve, we notice that we went through from 0 to pi, and by then we are already back to starting point. So it just took a range of pi radians for us to come back. Okay, we are done with this. Of course, we could have said from the beginning that it is a circle, and this is the circle that let's see, we fix one end of it here and the other end of it at this point. These circles, when you use the circle tool, you just specify a diameter and then you're all done. So since this is all a good match, we should get our answer. That so similarly with sine, or if the coefficient here is a negative, always remember that you're going to go in the opposite direction of the ray that you're opening. So you can always use this polar tool for getting basics or some points of the graph, and then make an educated guess as to what your picture happens to be. Okay, so I hope you do a lot of these things and get a sense of how the graphing in polar coordinate looks like. Until next time, good luck and God bless.